Section 7.4 is on solving logarithmic equations and inequalities. A logarithmic equation is an equation with one or more logarithms. To solve these, we want to write them in exponential form. Let's take a look at a couple examples here. So number one here, we need to solve log base 81 of x is equal to 3/4. First thing I want to do is to write that in exponential form. So that's going to be 81 to the 3/4 power is equal to x. Remember, take your base, raise it to the power of what's on the right side of the equal sign, and then it equals the number that follows the base. So the easiest way to solve this, you could just punch this into your calculator, but let's go ahead and do it kind of the exponential way. 81 is the same thing as 3 to the 4th power. And if I'm raising that to the 3/4 power, that equals x. Now remember, when you have an exponent inside and an exponent outside, we multiply them. So 4 times 3/4 is actually just a 3. So x is equal to 3 to the 3rd power, or x is equal to 27. Whoops. Okay. Second example, log base 8 of 1/2 is equal to x. We actually did one like this in the last section. Write it in exponential form. 8 to the power of x equals 1/2. And now I have an exponential equation to solve. The easiest way to do this is to write each of these numbers with the same base. The base I'm going to go with is 2. So this is 8 is 2 to the 3rd. That's raised to the power of x. 1/2 is actually 2 to the -1. Okay, so this is 2 raised to the power of 3x equals 2 to the -1. Since my bases are the same, I can pull off the exponents and make those equal to each other. So 3x equals -1, or x is equal to a -1/3. And you can check, actually you can check both of these in your calculator. For this one, what I would do is say, is 8 to the -1/3 power equal to 1/2, and it indeed is. And this one's a little more complicated. Log base x of 32 is equal to 5/2. So let's write that in exponential form. X to the 5/2 power equals 32. Now this actually looks a little more normal because our x is actually the base, which we're kind of used to seeing. To solve this, I would like to get rid of the fractional exponent. So I'm going to multiply both sides by 2. And I chose 2 because when I multiply 5 over 2 times 2, it's going to get rid of the fraction and just leave me with x to the 5th equals, I'm just going to leave that 32 squared for now. And now to get rid of that 1/5 and get x by itself, I want to multiply both sides, or raise both sides to the power of 1/5. Kind of doing the same thing here. And the right-hand side of this equation is starting to look a little messy. We'll deal with that in a minute. So x to the 5th to the 1/5 power, remember again, multiply those exponents, that's just going to give me x to the 1, equals, now this looks a little messy, or actually it's not, probably not too bad. So that would be 32 to the 2/5 power, which you could put in your calculator, but just for fun here, let's go ahead and write it with a smaller base. 32 is actually 2 to the 5th power. 32 is 2 to the 5th, and that's raised to the 2/5 power. And when I multiply those, 5 times 2/5 is going to give me just 2. 2 squared, or 4. So my final answer is x equals 4. And you could go back up to here where we wrote it in exponential form, and in your calculator check that 4 raised to the power of 2/5 is equal to 32. Okay, now for solving logarithmic equations that have a log on both sides, it's very straightforward. If log base b of x is equal to log base b of y, then x equals y. Notice, both say log, both have the same base, so if they both have log of the same base, then the x and the y just equal each other. So let's take a look at this one here. So log base 3 of the quantity x squared minus 15 equals log base 3 of 2x. They are both log base 3, so I can just pull off x squared minus 15 equals 2x. You might want to say cancel out the log base 3's. Technically that's not what you're doing, but you can think of it that way if you'd like. Now this is an interesting equation because this is actually quadratic. So I need to make it equal make it equal 0 and factor the left hand side. That's going to factor into x minus 5 and an x plus 3. Each one of those should equal 0. So x equals 5 and x equals negative 3. But I can't have a negative 3 because you can't take, so for example, if I were to plug that back into here, log base 3 of 2 times negative 3, you can't, that's undefined. So in this case, we can't have the log of a negative number, Technically, log base 3 of negative 6 is undefined. So this is one of those cases, if you do get a negative number, you have to cross it out. We have only one answer, x is equal to 5. So for solving inequalities, so the first case, if log base b of x is greater than y, then we say that x is greater than b to the y, so b to the y, okay, x is going to be greater than b to the y. If log base b of x is less than y, then x is between 0 and b to the y. And if log base b of x is greater than log base b of y, then like the last case, we can just pull off the x and the y. So let's take a look at a couple examples here. So here we have log base 3 of x is greater than or equal to negative 4. To write this is a little bit different. Normally we'd want to say 3 to the negative 4 power and then keep the sign, but we're going to keep the x there. We're going to keep the greater than or equal to, and then I'm going to write this in exponential form, 3 to the negative 4. Okay, 3 to the negative 4 is the same as 1 over 3 to the 4th, or x is greater than or equal to 1 over 81. So it's a little bit different in terms of the way you write it. Keep your x there, keep your greater than sign, and then use the base and the number on the right hand side to write it in exponential form. In our last example here, log base 11 of 3x minus 24 is greater than log base 11 of negative 5x minus 8. Notice both sides of this inequality are log base 11, so I can just pull off the 3x minus 24 and say that's greater than or equal to negative 5x minus 8, and then just go ahead and solve this as a regular inequality, adding 5x to both sides and adding 24 to both sides. X is greater than or equal to 2.